Okay, earth science time. Today we are talking about weathering, erosion, and soil. I wish I had gotten more tea when I was over here. Weathering, erosion, and soil. How do you reckon we're going to start this out?
Great. All right, science time.
You've been doing this, well, we already did that actually, but you've been doing this, you've been doing this for 4 years, some of you longer. Weathering, some of you for not even a week yet. Weathering, comma, erosion, comma, and soil. Let's put a nice little curly here. There we go. That's step 1, is put the curly. What is step 2 going to be? What am I going to say next? Define. I'm going to do it in a dork voice because that's who I am as a dork. I'm going to push my glasses up and say, define weathering, erosion, and soil. What is weathering? What is it? Okay. Breakdown. Breakdown of rock into what? What's the object of this sentence? Subject? Yeah, breakdown of rock into sediment. What about erosion? What's that? Is this mic picking up? Is the mic picking up? Yes, it is. Okay. What's erosion then? Yeah, the movement of the sediment. Movement of the sediment. Can you guess what soil might be?
Sediment.
Is it only sediment?
No, it's I would say.
What's a good noun to start with for this? A more basic physical noun of what we could start with to describe soil.
Sediment mixed with
organisms added. Yeah, sediment mixed with. And so what's a good noun we could use to describe the soil? It is primarily, firstmost, that's what primarily means. It is a what? Mixture. A mixture of sediment, organic matter, and organisms. There's probably some water in there too. Okay, we have defined our things, right? We could, I guess, hypothetically, we could stop there, but we're going to go a little bit deeper into each of these things. We're going to talk primarily about the types and causes of weathering, the types and causes of erosion, and I really want to say types and causes of soil, but causes of soil doesn't make a huge sense. But we can still call it that. That'll make it more poetic if we have for each of these things the types and causes. Well, in fact, we could probably even make this into a nice little table. I like tables. I'm trying to think if this would work as a table. And now I'm trying to think if this won't work as a table. Let's try it as a table. I've never done it this way before, but I like this kind of graphical way. Types and causes. And I'm going to leave myself a little like room over here to do some drawings and stuff. I love to do some drawings and stuff. Types and causes of each of, this is going to be beautiful, weathering, erosion, and soil. Oh, I like this very much. This is going to be so good. It really is. This is almost, without tooting my own horn too much, it's really kind of a genius. This is a stroke of genius to have this nice table for the types and causes of each of these. Speaking of stroke of genius and how I'm not having one, our objective is to diagram the causes and effects of Earth's surface processes. Diagram the causes and effects of Earth's surface processes. And this probably will stay the objective until we start talking about ground and surface water, or maybe even through surface water, since surface water is a surface process. So my point being that we will probably have this stay the objective beyond just this particular lesson. What can you think of what might be the types of weathering? You've probably heard of these before, is why I'm asking you this kind of open-ended question. There are two basic kinds of weathering.
Water, or no, chemical is one of
Yep.
them, and mechanical
Yep.
is the other.
Yep, I'll say either physical or mechanical. Mechanical is more usually said, but you could call it, in order to relate it to kind of what we learn in physical science about physical and chemical changes, we'll call it physical or mechanical weathering, and there's also chemical weathering. What do you think these, and the reason I like this physical word here and chemical is to relate these back to what we understood from chemistry, and for those of you who have taken chemistry, and physical science for, I assume, all of you. What might be the difference in what changes, depending on whether it's physical or chemical weathering? In physical weathering, let me give you the sentence frame. In physical weathering, what probably doesn't change?
The makeup of
Yeah,
it.
exactly right, Allie. Very good job. Makeup stays the same. What then does change?
The appearance.
Yeah, maybe let's be a little bit less specific. More specific? Either more or less specific. What changes about it? Give me an example, let's say, of we could put in the causes category of physical weathering. It'll help us to think about if we have an example. Can you think of an example of physical weathering?
Yeah.
Okay, so could wind break down rock? That's what weathering is. Sure, especially where it carries other rock. It could break a rock, sure. So that would be physical weathering. So what is staying the same? If we imagine a little bit of rock coming and hitting a big bit of rock and knocking a piece off of that, did the makeup change? Well, we said the makeup stays the same. So in this case, it isn't physical weathering. What did change about it, though? She said appearance. It says you may be having performance issues. That's kind of rude. I don't know what that meant. It seems to be better now. Size, shape, things like that. Form, we could say, changes. Size, shape, I'll put etc. change. What could cause this? Well, we said wind.
Water.
Oops. I'm going to be more specific with wind. Let's call this one abrasion. Do you know what an abrasion? Have you heard the word abrasion before? In what context have you heard the word abrasion?
Like
Yeah, you can get an abrasion on your body. What is an abrasion on your body? Is the medical term for what? Nope, that would be a contusion. Nope, that would be an incision. You've had an abrasion. I know you have. A specific kind of rash that you might get from a specific location that they're usually named after locations, like road rash or probably court burn is what they call it, I would say, but that's actually it's not a rash. Both of them are abrasions. And in abrasion, the skin, this is a medical abrasion, the skin has been rubbed away, right? So that's an abrasion medically, but it does relate to this. The wind abrasion is where material carried by the wind, that's the sound it makes, hits something else, and that stuff is carried away in a similar way to how your skin would get carried away by the road, for instance. Yes, Mons. Shape. Yep. What are some other causes of physical erosion? These are not to be exhaustive, non-exhaustive. We're not listing all of them, in other words. What's another cause of physical erosion? I did say erosion, and that's not what I meant. And maybe that's where the confusion comes from. I mean, what's another cause of physical weathering?
water.
Water. Can you be more specific? Rain. Yep. How can rain actually break down rock? Yeah, it can. So it can, depending on the consolidation of the rock. For instance, if we had something like conglomerate, just being wet might cause chunks to fall off of that. But it can also cause what's called frost wedging, which is in the form of ice. I'm going to draw a little picture of that over here. So if we have a rock that happens to have a crack in it, how can a rock get a crack? Lots of different ways. Give me one.
Force.
Hammer. I like that, actually. Force is very, very broad. You're right, though. But I'm going to put also on here bio. What does bio mean? Life. Look out there. What is that man doing?
He is moving rocks.
He is moving rock. What's that called? The movement of sediment.
Weathering.
No, the movement of sediment. Does that count? Is what he's doing erosion?
It is moving and changing the.
Does it count? Does that count as erosion?
No.
Yeah, it does. A lot. We sometimes in things like biology and chemistry, we kind of trick ourselves into thinking that things that human beings are or do aren't really part of this. Like we're studying nature, so we don't want to think about human beings, but we do consider human activity, bioactivity, any kind of life, not just humans, to be weathering and erosion. So imagine, do you think that as he's doing that, any of those rocks are breaking? Probably, yeah. His main purpose is to move the rocks, but I'm sure some of them are breaking, and that is biological erosion. So maybe biological weathering is also biological erosion when they move. So maybe this crack gets there because of something a human being has done. A hammer, for instance. Okay, so there's a rock, it gets cracked by your boy with a hammer. Now it has a crack in it, and then into that crack, what's the blue represent?
Life.
Water. Water gets in the crack, and then what's the snowflake represent, Elsa? Yeah, it freezes. The ice, water as it freezes expands, and it separates this crack into a bigger crack. And that's called frost wedging. Frost wedging, starring Elsa from, what is the place they're from in that movie? Arendelle, of course, I'm sorry. Let's talk about chemical weathering. Chemical weathering is another type of weathering. If we define physical or mechanical weathering as that it's that breakdown in which the makeup stays the same, how could we define chemical weathering, do you reckon? Say again. Oh. Yeah, acid rain is an example. I'm going to put that over here, actually.
What can cause acid rain?
Well, we will talk about that in a second. Acid rain is an example, but I'm looking for if physical weathering was that in which the makeup stays the same, but the shape changes, or the size or whatever changes. In chemical weathering, what probably does change?
The
Yeah.
chemical makeup.
Yeah, the composition or the chemical makeup, either of those is fine. Composition does change. So whatever it was before chemically, it is no longer exactly that same way. Acid rain is one. Oxidation is another. We usually include dissolution in this. Explain acid rain to me. Someone said, what causes acid rain? Let's have another little pull out here. What's acid rain? What's it largely made of, if you had to guess? Mostly what? Well, kind of a trick question. Yeah, it's mostly water. Acid rain exists when the atmosphere has some gas in it, such as sulfur trioxide or carbon dioxide. And as the water from a rain cloud falls through those, what's the water made out of?
Water.
The water is made out of water. You got it. The rain is H2O. And as the H2O and either the CO2 or the SO3, there can be other things too, but those are two of them. You'll remember from chemistry. Ooh, this is going to be really cute. I'll do this one in green so it's like acid. Astute observers of chemistry will know how to name this. What is H2SO4? It's hydrogen sulfate. As an acid, we name that. The H becomes ick, and now it's sulfuric acid. There we go. So these things that were in the atmosphere as gases, the SO3, sulfur trioxide, or the CO2, carbon dioxide, when they combine with the water, they form an acid. And this acid then has the power, you might even say, to chemically weather. Here I have this beautiful picture that you don't have in your book because you have a different book from me for this, of this lion. Look at this statue of a lion. What's he look like? Weathered. Do you see? Yeah, he's got, his features have been worn away because the rock out of which he was made, limestone, when it combines, you remember that one of the ways that we test for calcite, the mineral calcite, is to put acid on it. And if it bubbles, it reacts, and that is the mineral calcite. And as a rock, that mineral is called, among other things, limestone. Oxidation is the combination of something with oxygen. Think about like rust. Rust is an example of chemical weathering. And then dissolution is the noun version of the word dissolve. So when that calcite dissolves in water, that's dissolution. It has dissolved, and that's chemical weathering. And we'll come back to calcite and water when we talk about ground and surface water, because that's a really important chemical reaction. But in each of these cases, the thing has changed. Its composition, it's a different stuff than it was before. And that's what's important about chemical, or that's what makes it chemical weathering. Now, let's move on to erosion. Oh, wait, before we do, what might make this chemical weathering progress of any of these kinds or other kinds? Remember, this is non-exhaustive. What might make it progress more quickly? You might remember this from your solution chemistry, Tiana and Lily, since you've been in Chem 2. What might make these things faster? There's two main ones that apply in nature. Yeah, the warmer it is, the faster these occur, as most chemical reactions. That's not true of every chemical reaction, but in these chemical reactions, that is true. So the warmer the environment, the faster this occurs. What else? Did someone do one with sugar cubes and powdered sugar or powder? Okay. That was because of the difference in surface area. So basically, if we have, I'm going to put this one over here because I ran out of room on the other side. If we have this sugar cube of a certain volume, we'll say it's 1 cubic centimeter, versus a pile of powdered sugar with a total volume of 1 cubic centimeter, which of those will dissolve faster? Remember, dissolve, the noun of dissolve is dissolution. Which of these will dissolve faster? The powdered sugar will, because it has a higher surface area. Because basically, what happens in dissolution is the water physically separates the atoms that make up the sugar one from the other. Basically, the more of this the water can touch at a time, the faster that can happen. So in this case, the water can only get to the outside ones first. Once those are dissolved, the inside ones, et cetera, et cetera. So it's like a nesting doll. Whereas in this, it scatters out, and that happens much faster. So this is about surface area. The larger the surface area, the faster the weathering, and the higher the temperature, the faster the weathering in general. What is erosion? We already said it is the movement of sediment, but what might cause that? We have some types of erosion here that we're going to list. What are the types of erosion? Or can you think of any types of erosion? Remember, erosion is the movement. Okay, river. We call that fluvial. Each of these, maybe not each, but most of these have a fancy name too. So I'm going to put the name that we would normally call it, or its environment. We call these erosional media. A medium is something through which another thing is able to happen. Media is the plural of that word. So we're giving the different erosional media here. Erosional, like erosion all, media. Fluvial. Fluvial. What's another way that the sediment can be moved from place to place? Wind, which the fancy word for that is aeolian, with the AE. What else? I didn't hear you.
Animals.
Yep, bio, again, biological. That's just biological. It's already fancy. What else? What's that made out of?
Water.
How else could that move stuff?
Rain.
Okay, we could. I'm going to put rain, and I'm going to put it. To me, the closest relates to rill and gully erosion, which we'll talk about more in the next unit. Okay, what else? Tsunami. Where does that happen at? The ocean. I like that one. Ocean. We call that marine. Is there anything that's like a little baby ocean that you can go to? A lake, which we call lacustrine.
Running out of room here.
I'm not. And then one more. There are more. Okay, two more. I'm going to put glacier. And now I am running out of room. And I'm going to put mass movement. I'm going to abbreviate movement MVMT because I did run out of room. Mass movement. Mass movement is where Do the rest of these all make sense? I mean, I know there's a fancy word, but besides mass movement, do all of these, are these kind of sense making already to you? We will talk more in depth about how specifically these things manifest erosion. But you know what they each mean except for mass movement. Yes or no? Yes, okay. So a mass movement, I'm just going to bring this over here, is, I'll put sediment moving solely by gravity. So when gravity is the main thing, I put that in the causes for a reason. When gravity is the only thing that is instrumental in the movement of this sediment, we call that a mass movement. For the rest of these, what else is contributing, as we already said? Water. Water. That's one of the reasons. There are two main reasons why Earth's surface is so dynamic compared to other celestial bodies that we observe. One of them we talked about in the last unit was plate tectonics. The other one is the presence of water. Because water can do dissolution. It makes acid rain. It can contribute to oxidation. It's instrumental in biology, you know. Nothing lives that we know of without water. Water itself is the weathering. So the water is kind of the key to all of these processes. What is the driving force of this water? What is the actual, water itself is not a force. What is giving the force, the movement behind this water? Once again, gravity. So almost all of these are driven by gravity. I should not have drawn it to this one because that's the other one we're going to talk about, which is Aeolian. What is the driving force behind the wind? It's not gravity. Gravity doesn't cause the wind, or at least not in the...
Like a long time ago.
Wind is caused by differences of what in the atmosphere? No. Pressure. I'm going to put ATM standing for atmosphere, atmospheric pressure. That's just kind of a basic rundown of erosion. Okay, do you have questions about weathering or erosion so far? Okay. For the types of soil, first of all, there are types of soil. But the first thing I want to do for this type of soil is draw this diagram of what we call soil horizons. If I remember right, I think that your book might give these in inverted order, and maybe it has just, like, they've changed, like soilology has changed since this book that I'm using was published, but I don't think so. I think it might just be wrong. The top layer of a soil is called the O horizon. Can you guess what O might stand for in O horizon? No? Good guess, though. That does start with O. What else is soil made out of besides sediment? Organic matter. The O horizon is the layer of organic matter, which we sometimes call humus. How do you spell hummus? Is that two M's?
H-U-M-M.
The other way, with just one M, is how you spell humus, which is what we call the kind of collection of wet-ish decaying organic matter that's found in the top layer of the soil. The next layer down is called the A horizon. The A horizon is sediment with organic matter. Below that, can you guess? B horizon, which is mostly sediment. And then the C horizon is mostly broken down bedrock. And then below the soil is what we call the bedrock. Whatever the top layer, don't get confused, because in Minecraft, bedrock is the bottom, but in real life, bedrock is the top layer of actual rock. So there can be soil. In fact, there usually is soil above the bedrock, but the top layer of actual rock is called bedrock.
What's the horizon?
I said it's broken bedrock. It's mostly made of the same stuff as bedrock, but it's broken down. The B horizon is sediment made thereof, And then the A horizon has some organic matter mixed in, and the O horizon is mostly organic matter. Now, don't get me wrong. These things are not like meant to serve as two-scale ratios. It's not like it's always a quarter O horizon. In fact, the ratio of these kind of determines the fertility of the soil in an area. So there might be very little or no O horizon. There might be a very, very expansive C horizon. And the ratio of these changes from place to place. It also changes based on, guess again, the climate, the warmth, and the moisture of the area, and the surface area of the sediment. And there are all kinds of soils. I don't think your book goes into very much detail about what kinds of soils there are. And the places on the test where these are mentioned are things like, I'll even just show you this on the test. This is kind of like a MAPS test style question where it gives you different types of soils, but you are not expected to know ahead of time. And then you read this chart based on the kinds of soil. So you don't have to come into it knowing about iridosols and mollisols and entosols. It'll tell you about them, and then you'll do a problem based on them. But there are different kinds of soils, and they all end in the suffix sol, which is the Latin word for soil. So that kind of makes sense. In fact, I'll just read them to you, and you can kind of, this book gives you some, and there are more than this, but I'll read you a few of them, and you can look them up on your own if you want to. They are alphasols, andesols, artiosols, entosols, geliosols, inceptisols, mollisols, orosols, spotisols, vertisols, etc. There are many kinds, and they all have different attributes, and you can look those up on your own for fun. They will also be on your test, but as things to look into, not things you have to have memorized. You'll remember that I didn't really want to have a causes of soil. I mean, can you tell me what is the cause of soil primarily? What is made mostly out of organic matter and sediment, as we said. So you could say soil is caused by what? Weathering, in the case of the sediment. What causes it in the case of the organic matter? Death. I'm just going to put death. Death, life. Yeah. Again with the talking about death. So that ends the table. But I also want to show you this before we go. I want to show you this idea. I'm not going to draw it, but I will show you from this book this idea of what's called a ternary diagram. And these exist for lots of different things. And the reason I like to show this is because this is like a whole class of diagrams that you can read. In this case, it happens to be about soil. Well, it doesn't happen to. It is about soil. But in other cases, it might be about something else. But it's basically a way where a normal chart like this with an X and a Y axis is used to compare two things. A ternary diagram is used to compare three things, maybe X, Y, and Z. And you read them by running up a line on this one with a line on, I don't know, this one, and then you link them to another line on this one, and then where they cross is that thing that you're talking about. So you will be expected to learn how to read a ternary diagram for your test, but hopefully we will have some time to work on those a little bit beforehand. Do you have questions about soils, weathering, or erosion? Do you have questions about soils, weathering, or erosion? Do you feel like you learned anything about soils, weathering, and erosion? I don't have any illusions about the fact that I probably missed some stuff that you will be tested over, so we'll talk more about that in the future. But for now, I think this will get us a pretty good start.